So, hello everyone. Today we're going to be finding the area of a circle with a radius r. Or better said, we're going to be deriving the formula for the area of a circle with radius r. So, I'll just start by, okay, maybe I'll go ahead and use the ruler. I'm gonna start by drawing our standard xy coordinate system. So this is our x-axis and this is our y-axis. And I'm going to try ahead and do my best to draw a circle with a radius r, whose center is at point 0, 0. Okay, so we're going to be using calculus, namely finding the area under the curve. And what I really want to do here is I want you to notice that this circle is split up into 4 equal parts. Okay? So we're going to be calculating the area for a single of these pie charts, and then we're going to be multiplying that area by 4 to get the area of the entire circle. Okay, so let's get started. So the general equation for a circle is x minus its x coordinate of its center squared plus y minus the y coordinate of its center squared is equal to its radius squared. Since this circle of ours has since we've set it up in such a manner that its center is at point 0, 0, we'll get that its formula is x squared plus y squared is equal to r squared. Okay? And from here, we get that y is equal to the square root of r squared minus x squared. Now, we know that we're going to be computing the area of 1/4 of this circle, so p over 4, and we know the following part from calculus, is going to be the integral from a to b of y of x dx. Okay? Nice. So first we have to find our limits of integration. So we have to make y equal to 0. Okay? So our limits of integration are going to be so x squared is equal to r squared. So x is equal to plus or minus r, but that's for our entire circle. And so the point here is minus r, the point here has the x coordinate of plus r. And so the complete length of this part right here is 2r, 2 times the radius, right? But so we have to divide it by 2. And what's the point of this coordinate right here? What's the coordinate of this point right here? Well, it's 0. So pi over 4 in this case is equal to the integral that goes from 0 to r of y of x. Instead of that, we're going to be putting in the square root of r squared minus x squared dx. Okay, now we can just go ahead and compute this integral. So what I'm going to do right here is I'm going to use a trigonometric substitution. Namely, I'm going to say that x is equal to r sine t. Let's call it t. And from here, dx is equal to r cosine t dt. Okay, so from here, dx is equal to r times cosine t dt. Okay, and t1 is going to be equal to x1, which is 0 over r, and arc sine of 0 is 0, so t1 will remain 0. And t2 is going to be the arc sine of r over r, so arc sine of 1, which is pi over 2. So I'm going to be getting the integral from 0 to pi over 2, r squared minus r squared sine squared t, r squared minus r squared sine squared t times r cosine t dt. Once we factor out the constants, we'll get r squared times the integral from 0 to pi over 2 of the square root of 1 minus sine squared t times cosine t dt. And if you remember this is the same as cosine t. So, and we'll get, when we multiply it by this part right here, we'll get cosine squared t, which can be rewritten as 1 plus cosine of 2t over 2. So I'm just going to factor out the 2 right at the start. R squared over 2 times the integral of pi from 0 to pi over 2 of 1 plus cosine of 2t dt. Okay, and this is going to be equal to r squared over 2 times t plus sine of 2t over 2. And everything between the limits of 0 and pi over 2. So this is going to be equal to r squared over 2, and let's go ahead and plug in these values. So instead of t, we'll just put in pi over 2 plus sine of pi over 2 minus 0 minus sine of 0 over 2. And of course, sine of pi is equal to 0, and this is 0, and sine of 0 is also equal to 0. So we're just left with r squared times pi over 4. And if we look at the beginning of this problem, this means that pi over 4, that p over 4 is equal to r squared times pi over 4. And we can cancel out the 4's, so we're left with the formula for the area of the circle being r squared times pi. So this is the final answer to our problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.